Hello, and we're back. We are solving similar triangles today. You'll notice we have this statement here, and this symbol here, this little wavy line, what I might call a tilde, means these two objects are similar. Triangle MPQ is similar to triangle RZV. MPQ, RZV. And you'll notice that there are some blanks here, and we want to figure out what those are. Okay? There's a blank side here, there's a blank side there. Okay, I'm going to just introduce some variables. Sometimes it's nice to introduce a variable. I'm going to put a y here, and I'm going to put an x here. And those are the ones that we're going to solve for. Okay? Now remember that for similar shapes, the sides are proportional. Okay, so we can write ratios for these sides and solve for the variables. I'm going to write the ratios of the sides just so we're on the same page here. I could say side QM, this side here, which is 4 here, is proportional, right, to, this is the longest side here, to side VR here. Okay? You can also see that the order here, QM, is proportional to VR. And whatever that ratio is going to be the same ratio for other corresponding sides. So, for example, QP is to VZ, and MP is to RZ. Okay? So, I'm going to use these to set up what I have here. So the two longest sides, QM to VR, those are the two that I have, right? 4 is to 20 as QP, which in this case I labeled as Y, is to 15, VZ is to this. MP is to RZ. MP is 2. RZ in this case is X. Okay? So here are my proportional statements. I'm going to solve the first one over here, the one with y in it. I'm going to say, okay, well, 4 over 20 is y over 15. Now, if you're not sure how to solve this, I'll have a link in the description to the video I just made about how to solve proportions. But I'm going to use this technique right now. I notice that there's a relationship between the denominator and the numerator here, and I'm going to use the same relationship here. Okay, so I notice that if I say, what can I do to get 20 from 20 to 4? I can divide by 5, right? I can divide by 5 or multiply by 1/5, right? And so, in the same way, I'm going to do the same thing on this side. 20 divided by 5 is 4. 15 divided by 5 is what? Well, that's going to tell me it's 3, right? So I know that y is 3. Okay, and I'm going to set up this second one over here. I'm going to use 4 over 20 equals 2 over x. 4 over 20 equals 2 over x. I could do the same thing, but in this case, I'm going to kind of go the other way, and I'm going to say, okay, well, 4 to 2, what do I need to do to get from 4 to 2, right? I'm going to do that same thing to get from 20 to x. So 4 divided by 2 is 2, but I'm going to write even 4 times 1/2. Divided by 2 is the same as times 1/2. So what is 20 times 1/2? What is 20 multiplied by 1/2? Well, half of 20 is 10. So I have y equals 3 and x equals 10. That's how I solved these similar triangles. Now sometimes the answers aren't quite so pretty. So let's take a look at another example, just one more. It's a little bit more complicated. Okay? So here you can see these are oriented similarly, where we have these two sides, we have those numbers. We're going to look for this one, we're going to look for this one. Okay, I'm just going to label this over here TK as A and DF as B. Alright, so again, I'm going to write my my ratios here. TG is to ED, as tk is to ef, as kg is to fd. Okay? So if I set that up, right, tg is to ed, it's 10 is to 6, as tk, a, is to ef, which is 7, and kg, 14, is to fd, b. Alright? So in the same way, I'm going to set this one up first. 10 over 6 equals a over 7. Another proportion. In this case, it's a little bit more difficult to see the relationship between 6 and 7 or 6 and 10. So I'm going to do this one algebraically. And again, you can click on the link on how to solve proportions if you want more information on that. But if I have a here, I just want to do the opposite of divide by 7. So I'm going to multiply both sides by 7. I'm going to remember that means 7 over 1. 7 is the same as 7 over 1. I'm going to distribute that, and I have 10 times 7 is 70 over 1 times 6 is 6. On this side, 7 over 7 is 1, and 1 times a is a. Can I simplify this a little bit? Right? This is the same thing as 35 times 2 over 3 times 2. And 2 divided by 2 is 1. So 35 over 3 times 1 is just 35 over 3. So that's what a is. Alright? Now we're going to do this one over here. We have 10 over 6 equals 14 over b. Now for this one, I would prefer the variable to be on the top. So the nice thing is, with proportions, I can just make it so. I can just do it. I can take each one of these and flip them over, the reciprocal, right? So 6 over 10 equals b over 14. Nice. And then I notice that I can simplify this. And while I could just keep going and solve for b, if I simplify this, the numbers are going to be a little bit smaller earlier, which in this case I can tell is going to help me. So this is the same thing as 3 over 2, or excuse me, 3 times 2 over 5 times 2. And 2 over 2 is 1. So I have b over 14 equals 3/5. And then like this one over here, I'm going to multiply by 14 because I want to get rid of divide by 14. Multiply both sides by 14. And I have, let's see, 14 times 3. Just so you know, 14 times 3 is the same as if I took half of 14 and doubled 3. 14 times 3 is the same as 7 times 6. I don't have 14 times 3 memorized, but I do have 7 times 6. I know that one. That's just 42. So that's what 14 times 3 is. 1 times 5 is 5 on the bottom there. And again on this side, 14 times b, I'll write it out this time just to make sure you get it. 1 times 14 is 14, but 14 over 14 simplifies to 1. So b equals, and I can't simplify that side, 42 over 5. So now I have these two variables, and they are pretty numbers, but that's okay. Sometimes that's the way it is. I hope that was helpful, and we will see you next time.